So today we're switching gears from prime factorization to greatest common factor. And we are actually going to use some of our prime factoring to do this section as well, which is why we learned that first. And the greatest common factor is often abbreviated GCF. So if you see GCF, you know it means greatest common factor. And the definition of greatest common factor is the greatest number that is a factor of two or more numbers. And so we're going to do some examples and you'll see exactly what I mean by that, okay? So here's our example to find the greatest common factor. They give me two numbers, 12 and 20, and it says find the greatest common factor of 12 and 20. So the first thing I have to do is write out all the factors of 12 and all the factors of 20, not just the prime factors, but all of them. So we did this a couple weeks ago. See if you remember. So I know 1 and 12 equals 12. Yes, good. 2 and 6 and 3 and 4. And remember, when your numbers meet in the middle like that, 3 and 4 are right next to each other, you're done. You found all the factors. Okay, so write them in order from biggest to smallest, and you'll easily see when you're done. So now I'm going to do the same thing for 20. I'm going to write all the factors of 20. So I always start with 1 and 20. What else? 2 and 10. Good. And 4 and 5. And that's it, because 4 and 5 are next to each other, so now I know I'm done. Now, I'm going to look for the greatest common factor. Here's the thing. I see that 2, they both have a 2, but we have to see if there's something bigger because we're looking for the greatest common factor. Is there something bigger than 2 that they both have in common? 4. They both have a 4, so that's going to be my GCF. So you're going to write GCF equals 4. Because that's the greatest factor that they both have in common. And remember, a factor is just something that you multiply together to equal a bigger number. Again, I'm going to start out by writing all the factors of each number. So for 6, always start with 1 and 6. And what else equals 6? 2 and 3. And 2 and 3 are right next to each other, so I'm done. And what about 8? 1 and 8. 2 and 4. And then that's it, because 3 nothing times 3 equals 8. So that's it. Okay, so what is the greatest factor that they both have in common? 2. This time there's nothing bigger than 2, so you're going to write GCF equals 2. So when you do these problems, I need to see all of this. Everything I'm writing, I need you to write. This is how you do the problem correctly. So what are the factors of 21? 1 and 21. 3 and 7, and that's going to be it for 21. How about 45? 1 and 45. 3 times what equals 45? 5 and 9. Good. Okay, and then I keep putting my comma in the wrong place. I think that's it. 1, 3, 5, 9, 15, and 45. Okay, so what is the greatest number that they both have in common? 3. So GCF is 3. So I encourage you, when you are doing your greatest common factors, circle the greatest common factor. You see how I'm highlighting? I want you to circle it, because you need to let it stand out to yourself or you're going to get lost in all the numbers. Okay, so here's our factors for 16 and 56, and we did use our calculator a little bit on 56 because there's a lot of them for that one. So now what is the greatest common factor that they both share?
8.
Ah, good. I was actually going to say 4, but you saw 8, so that's awesome. Good.
I was going to say 4.
Good job, Braden. So sometimes, I just want you to note, sometimes the last number, hold on, let me do this. The last number will be a factor with something in your bottom row. So pay attention. Don't just say, oh, because it's the last number, I don't use it. Sometimes you will actually use that last number. So pay attention to that. And right now, I want you to pause the video and write all the factors of 12, 24, and 36 without me. Go. All right, so we're going to write all the factors for these numbers now. So make sure you have each one of these and you didn't miss any. And make sure I don't miss any either, because sometimes when I'm talking and doing this, I miss stuff. $36 has a lot. 4, yes. 9, and then 6, right? Okay, so what is the greatest common factor that these all have in common? 12. They all have a 12, so the GCF here is 12. Awesome. Okay, and we're going to do one more thing. So hang tight and I'll be right back. Okay, for this section, it says factor each expression. So an expression, remember, is a problem that does not have an equal sign, but we do have variables. So we're going to look at both numbers that they give us and see if there's anything we could take out of both of them. So what is something that they both have in common? And I'm going to show you with number 13. I know that I can take a 3 out of this this expression. If I take 3 out and then use parentheses to show the distributive property, let's see what I would have left if I took a 3 out. And we're thinking multiplication or division here, okay? So if I take the 3 out of the 3n, I just have an n left, right? What if I take 3 out of the 9? What is 9 divided by 3? 3. So we just factored that expression by taking out a 3, something that both of the values had in common, and we just took it out and now put it on the outside of the parentheses. So if I were to do the distributive property and multiply it back together, I should get the same expression that I started with. So what's 3 times n? 3n. And what's 3 times 3? Did I get the same thing I started with?
Yeah.
Yes. So that is my answer. So number 14 is a little different because the first value in number 14 doesn't have a number on it. But what do they both have in common? They both have t's. What is the largest number of t's that they both have? That they both have in common? What? We're going to take t out of this expression. If I take a t away from the t squared, that means I'm left with 1t still. But if I take a t away from 4t, that means I'm just left with 4. And then if I use the distributive property and multiply it back together, I should get what I started with. So let's do that and see if it works. So t T times t is t squared, and t times 4 is 4t. So did I get what I started with? Yeah. So I factored it correctly. So this is my answer. Take 5 out of both of these values in this expression. If I do 15 divided by 5, I get 3. And if I do if I do 20x divided by 5, what do I get?
10.
20 divided by 5.
4.
4, and then keep the variable on it. Now again, if I use a distributive property, I should be able to get back to my original problem. So 5 times 3 is,
15.
and 5 times 4x,
20.
20x. Did I get what I started with?
Yep.
Yes, I did. So that is going to be our answer. And that's called factoring an expression. We use a distributive property to take something out, and then we can multiply it back together and get what we started with. Okay, that's all for today.